All right, hi everybody, and welcome to today's webinar. My name is Kelly, and I'm going to be the moderator of today's webinar. Today's webinar is all about indoor 5G, and in particular talking about the first 5G indoor deployment to take place in Brazil. Very exciting. The webinar is a joint effort between us, Ivywave, and QMC Telecom, and as such, we have two speakers today, our very own Milton Mulva, sales engineer at Ivywave, and Ricardo Rosa from QMC Telecom. And before we get started, there's a couple of housekeeping items. We are recording today's webinar. We will send out a copy to everybody who registered for the event. We encourage you to ask questions. Please use your GoToWebinar questions box to send them to us, and we'll get to what we can towards the end of the webinar. And with that, Milton, I'm going to hand it over to you to go ahead. Enjoy, everyone.
Okay, thank you, Kelly. Thank you, everyone, for the participation. Very welcome to Ricardo Rosa that will share the webinar with me. Hello, Ricardo.
Hello, Milton. Hello, everyone. Thank you very much. Very nice to be here. Thank you.
Okay. For today's webinar, we prepared an agenda, especially to present the first indoor 5G NR project in Brazil. I don't know if everybody is following the notice, but yesterday we launched the first commercial network in Brazil, in Brasilia, and now we have the first network real activated here in Brazil. And some months ago, Ricardo did this first POC for 5G NR. That was the first indoor project in Brazil. So we prepared an agenda just to talk a little bit about the IBS evolution from 5G to from 4G to 5G, focusing the key 5G features comparing to 5G, and talk a little bit about the 5G transitioning to 5G in indoor designs, and exploring a little bit about the 5G design best practices using IBA design, especially for system and settings, beamforming, and millimetric waves building modeling. Let's start talking a little bit about the IBS evolution from 5G to 5G, especially the principal key 5G features and challenges in the transitioning of existing designs. When we talk about the principal 5G features, we have a lot of new features, right, comparing to 4G, but here we will focus in three of them: beamforming, massive MIMO, and CRAN. And starting about beamforming, as you know, beamforming is a technique that shapes antenna pattern of antenna array in the preferred direction. This is done to direct the antenna pattern in direction of the serving customer, also called beam steering, and or to minimize the pattern in direction of customers that may jam the signal, which is also called null placement. The beam steering improves signal coverage, right? While null placement reduces interference. The overall result is improved signal to interference and noise ratio, which increase signal throughput and system capacity. Depending on the implementation, we can have three different beamforming architectures, right? Analog beamforming, digital beamforming, and hybrid beamforming. A very popular antenna array configuration is the uniform rectangular antenna array, where the antenna elements are placed on the orthogonal axis, forming a rectangular shape. This type of antenna geometry is characterized by the number of elements in the horizontal and the vertical axis. Here we have two examples, right? One 8 by 8 antenna array that will have a total of 64 antenna elements, and the another one with 6x16 antenna array would have a total of 256 antenna elements. This antenna array geometry depending of the sector that we want to cover, can have different angle, right, of coverage in the horizontal beam. So depending of the sector angle, we can have different arrays. One sample or a possible sample of the array with 8x8 antenna array is the horizontal beam for 120 degrees. In this case, using multiple antennas array, this 120 degrees sector can be covered with different narrow beams, right? For example, if you are using a 8x8 antenna array, we will have 7 narrow beams with 16 degrees each. Or if you have the same geometry but with 16 by 16, we will have in this case 8 degrees narrow beam, right? And then if you have these 7 beams to cover 120 in horizontal plane, and if we have 80 degrees in the vertical plane, then we need 5 rows of 16 beam antennas in the vertical plane, right? So we need to cover the 120 degrees in horizontal and 80 degrees in the vertical plane. We need 35 beams. And if we are using a generic 16 per 16 array, we will need 65 beams, right? And this is how the array, the antenna array looks in IBWave. So in IBWave, we can see the horizontal and the vertical planes, and we can have the aggregate beam, and we can have the individual beams in the antenna patterns view. The support of beamforming in 5G requires the ability to distinguish between different beams, right? So if you have a user equipment, the user equipment should be able to receive different beams and select the best beam for data transmission or for control channel information. This kind of support is possible through the special design of SSPBCH blocks, physical resource. Because the pattern of the SSB is the time domain, in the time domain is made in a timed sequence, each SSB can be sent with different beams. So we have different beams sent by different SSB sent by different beams. And we can have 8 unique SSB sequence that can be sent over 8 beams that must be cover the whole sector. So for this reason, if we compare a narrow 5G sector beams versus a wide 4G sectors beam, we can have a much more focus energy being serving different users in the network, right? One of the benefits of the beamforming is the massive MIMO, right? And the massive MIMO is based upon the 3 key concepts of spatial diversity, spatial multiplexing, and beamforming. And with the massive MIMO, we have a lot of benefits, right? We can have more active antenna elements, we can have more focus energy, less interference, more spatial multiplexing layers, better throughput and coverage, and of course, in the end of the day, large number of users server simultaneously. And the last key feature is the CRAN. CRAN is the network topology that separates baseband processing and the RF hardware, but it's not technically only for 5G, right? We already have CRAN for 5G. However, it will affect the capacity planning for indoor networks. So it deserves a special mention here as a key 5G features, right? And naturally, right now, we are looking for the networks moving to the Cloud RAN topology. And the impact of the CRAN on in-building designs is at the capacity planning stage, while calculating capacity requirements for busy hours, right? So as we have BBUs pooled, in-building network is not likely to experience MAC layer blocking due to insufficient number of BBUs at any area range, right? So with the CRAN, we can increase the processing and avoid these problems of blocking in the 5G networks as well. And regarding 4G transitioning to 5G, we have some specific challenges for indoor designs. Like the outdoor designs, one of the big issues is the backhaul, right? So how we need to plan our network to a specific traffic load, right? At each specific venue, we need to have the backhaul requirements for the whole network, considering the summation of the required throughput for each cell, right? So we need to pay attention in the backhaul, and these requirements compare against available dark fiber, right? Capacity in the building. So normally we can reach or attain this backhaul requirements using fiber right now. Another challenge for us in the indoor design is the millimetric waves. How we need very high throughput. We are, or the operators are considering deploying 5G networks at millimetric waves because we commonly have a large bandwidth, right? We can reach higher throughputs and higher data rates, right? But we have some restrictions for millimetric waves, especially regarding the propagation, right? So we need to pay attention in the indoor designs, and we can see now in the market more use cases for millimetric waves in some venues like stadiums or where the transmitter are deployed in some areas or more open space areas. Like another example could be an indoor hotspot, such as a cafeteria or a conference ballroom, or some indoor cases like open space areas, right? Another important thing is the conversion of existing projects, right? We have a lot of legacy 4G, 3G and 4G systems, and we have a lot of passive DAS networks, right? So we need to work with the passive DAS and make the conversion of passive DAS and transition the passive DAS from 5G to from 4G to 5G. And probably the passive DAS will be converted in a small cell design or in the active DAS design, or even in active radio DAS design, right? In order to transition from 4G to 5G systems. And another important thing is the migration from the sub 3 gigahertz bands to sub 6 gigahertz bands, right? Commonly, we have for 5G designs up to 2.6 gigahertz. In US, we already have the CBRS, right? So we already have the LTE for 3.5 gigahertz. But in some places like Latin America and in other places around the world, we have up to 2.6 gigahertz for LTE. So it's another challenge to start to work with 3.5 gigahertz, right? Specifically for you in the US and in Canada, you already have CBRS, so you already work with 3.5 gigahertz, right? But in some places is another challenge for the transitioning. Talk a little bit about the 5G design best practices in using IBA design and look for this 5G key features. One important thing in IBA design is the system configuration and the user equipment settings, right? Because in 5G, we have a lot of new concepts, right? In 5G, we have the concept of numerology, right? Whereby an operator may select among various sub-carrying spacing options, right? In comparing with 4G, for example, we have more flexibility and more options, right? The same if we consider, for example, the periodicity and the slot allocation. So we have a lot of flexibility and different configurations. And 5G gives even more flexibility when we are looking for bandwidth partitioning. So we can have a bandwidth partitioning in the same carriers as well. And regarding slot formats, we can have different configurations, right? So we can set, depending of the periodicity, we can set different slot allocations for downlink, for uplink, and all this configuration is important to generate the output maps using IBA design, right? So we need to pay attention in the system configuration and even in the user equipment configurations. So our best practice here is set your 5G profile properly according to the operator settings, right? And specifically for the user equipment, pay attention to the antenna again, because especially for millimeter waves, we have in the first devices in the market, we can see that the antenna gain is up to 6 to 7 dBi comparing to the sub 6 gigahertz devices, right? So for sub 6 gigahertz devices, you can leave the same settings here by default for LTE, for example, but pay attention when you need to do some millimeter wave networks. For beamforming, we need to pay attention regarding the calculations as well, because in IBA design, we can see the aggregate beamforming radiation pattern. That is the summation of the individual SSB beams, right? And this aggregate radiation pattern is used to calculate the SSRP heat maps, which indicates the node B's 5G signal coverage, right? But for the VEX file, we can model the not only the aggregate SS radiation pattern beams, but we can model the individual SSB and PDSCH beams, right? And the individual beams are used to calculate especially the PDSCH SNR and PUSCH SNR and the PDSCH maximum curable data rate and PUSCH maximum curable data rate. So pay attention here. You can always check radiation patterns in your 5G small cells and antennas. Just clicking in view patterns, you can see here in the beam type, in the beam drop-down menu, you can verify if you are looking for the beam forming pattern or for individual beams. So you need to make sure that you have both here, because especially for PDSCH SNR and maximum curable data rate, if you don't have the individual beams model, we will have PDSCH SNR and maximum curable heat maps inaccurate calculations, okay? And finally, for millimeter wave building modeling, we just need to pay attention because we have a huge difference in the propagation, right? Comparing a sub 6 gigahertz and the millimeter wave propagation heat maps, especially for the reflection, because for example, at 30 gigahertz, right? The wavelength is only 1 centimeter. So most objectives in your layout are much larger than the wavelength, right? So this will imply that you have a lot of reflections. So it's very important to pay attention in your millimeter waves. So we recommend to millimeter waves a more detailed building modeling as possible, including large whiteboards, mirrors, and flat screen TVs, because we have those objects reflect the signal, reflecting the signal, and much more in millimeter wave frequency, right? As you know, in IBA design, we have all materials already read for millimeter waves with all parameters for losses and reflection and diffraction to be used in our fast ray tracing propagation model, right? Now, the last one is near field and far field boundary. This is just to make sure that you determine your Fraunhofer distance and pick up antenna locations in order to don't have reflective objects within that distance, right? So avoid to install the antennas near reflective objects, right? Oops, sorry. Now I will leave Ricardo present to us the use case. Ricardo, you are mute.
Okay, thank you, Milton. Just set things up here. Okay, good to go. Well, good afternoon, everyone. Thank you very much for everybody to be here. It's a real pleasure to be able to share this experience with everyone. So I'm Ricardo Rosa. I work with QMC Telecom. We are a neutral host solution provider. We, as a company, we started it was founded in 2008 in Puerto Rico. And then 2012, we started operations in Brazil. So we are this year, completing 10 years. In these 10 years plans, we managed to do a lot of things. We are very proud of what we accomplished so far, especially when we talk about DAS projects in South America. So as somebody familiar with, the Brazilian market and the South American market is very price driven. But anyhow, we managed to accomplish a lot of designs and implementations for indoor projects. We have today in our portfolio of solutions, a lot of solutions. We have DAS, distributed antenna system. We have what we call SLS, the street level solution. We have fiber products, to deploy fiber across the building. And we are a full neutral host solution. We have towers as a tower sharing. We also have what we call PI. That's an acronym that we use for camouflage sites. And we have these sites in very peculiar locations in Brazil, in beach areas, historical cities that we cannot have any kind of visual impact. So we have this camouflage sites. We have pine trees, we have coconut trees, all kinds of types of camouflage. So today we have operations in 7 countries, including US. We just recently started the operations in US. So we have a team there in US. We also have operations in Mexico, Colombia, Peru, Chile, and Brazil. Okay. So our technical team, if we get everyone, we could consider that if we consider all the engineers that's part of our technical team, everyone, we were involved in more than 10,000 projects, that only considering that. So we are a very experienced team. We have people that work across the globe, have worked in all kinds of countries, in Asia, which they bring a lot of experience in Europe, even some places in Africa, US, Canada, Brazil, South America, all around the globe. So to be able to share this experience, let's talk about what we did here for 5G. So Brazil, this year we had the auction for the 5G frequency, and we auctioned 3 frequencies. We had millimetric wave, the 3.5 gigahertz, and also 2.3. So our 3.5 is very close to what you guys call C-band. But actually, if we consider the frequency band, the start and the end of the range, we are working more likely in our CBRS band. So here for all the operators, we have the bandwidth from, if I recall right now, is 3,400 to 3,800 megahertz. And we had a lot of doubts, So we started preparing for this new challenge since 2019. In 2019, we have the first case where we deployed 5G, but this was very specific case for a telecom event here in Brazil. And then this year we start to prepare for actual rollout. So we select this site. This is a site in Rio de Janeiro. And the reason we select this one is because of the amount of traffic that we get here. It's a site that's very close. It's a shopping mall that's annexed to the airport. And we also have a hotel here. So with this location, we were able to try and collect data in 3 different scenarios that was important for us. So the first one is the food court. This is a small food court, but very, very dense. So on this scenario, we were able to collect data to calibrate the propagation model and better understand how the 3.5 signal would behave, in a very dense environment. So this was very new for us. We also have this outdoor area. It's important to note that this solution is not a standalone 5G. You were doing a non-standalone with the anchor in 1800 LTE. And we want to check, if we were, the initial plan was to take different sets of anchor in non-standalone and also trial the system with a standalone configuration. But we had some limitations. We had to get a special permit from the government to try the system because it didn't have auction yet at the time we were doing the trial. So we only got 30 days to perform this trial. So we had to select. But the idea was to try something new, decoupling the uplink, and try to do different combinations of anchor. We have a traditional DAS here, MIMO 2x2 with all the frequency bands, 700, 1800, 2100, 2600, and we wanted to try in all of them. But at the end, we just considered 1800 because there's a similarity, of the coverage area between 1800 and 3.5 when you consider high MIMO schemes. So that was the implementation. So here on this area, the Uber area here we call, it's outdoor area. So here we could see how the system would behave in the user equipment, regarding handovers and everything. And we also have a hotel lobby, and this was the closest one that we could got from a shopping mall. And when we talk about materials, so this hotel lobby has a very reflexive floor, so we want to check that. There's the elevators, and also some heavy obstructions here for the signal, and we also have a lot of glass here to separate this. Let's call like restaurant, but it's not a commercial restaurant. It's just for the employees of the airport. So you also want to check this one. Okay? So with these three locations, you were able to collect a lot of data to support our findings, our expectations. So this is the antenna. The solution we are using is a full, let's call fiber to the antenna, fiber to the edge. And the entire solution, we only use RF cables in the POI interface, only the head end. All the other distribution units are done through fiber. And this box, we have 8 amplifiers with 8 integrated antennas. So we are able to perform here 8x8 MIMO scheme for 2 operators. So we have a high capacity link here on the fiber. We can process in simultaneous 1200 megahertz of bandwidth on this little box. If we need more, we can just run another fiber to each of them. Okay. So this is just the general architecture of the system. We still need the signal source from the operator. At this trial, the operator was using Huawei equipment. So this RAU delivers 8x8 MIMO. So we connect this to the POI, and we just have a jumper to the master unit. And in the master unit, we quantify and digitalize the system, and then we transport this through the optical interface to the remote units. And our equipment area, where we have the DAS head end, is a little far from the operator's equipment. We are around 20 meters. And this is the model that was used for Huawei, that Huawei deployed here on the site. And then we had to run the 8 cables to our head end. Now, to support this installation, we had a training. All the technical guys that were part of this training received this training from Rode Schwartz. They provide us with their scanner to take the measurements. Let's recall that we are talking about airport. At the time we were starting this trial, we start to see some movements in US. We always look to US market as a reference, and there was those discussions about 3.5, the 5G in the airport area, about the radio altimeter of the airplane. So we had this concern. So with this equipment, we could monitor the spectrum to see if we could get any interference signal, or if we were generating any interference signal at the airport operations. So here we have this spectrum to just monitor all the spectrum. We also were able to connect our test equipment to this spectrum analyzer, so we could decode all the layer 3 messaging to understand better the states, of the user equipment, when it's connected, what's the watch time, all those parameters, and what we could work as an optimization parameter. I will talk about later on some of these findings. Okay? And we also had a board where we could see in real time all the measurements that was being taken, throughput. One of the things that we learned for example, we're talking about indoor. We have a 8x8 site, so we start the configuration with 8 beans, and then this generates a lot of interference between the beans ID. So we have to step back and then we configure just 4 beans ID, and this looked to be the most optimal configuration for indoor deployment. Another thing that we saw is the power consumption. So at the beginning, just when we commissioned the site and we started the first tests, we were trying here on a CISO system, just one antenna port activated. And soon we start to run some data, not through the system, the site would shut down and come back up again very fast. So we are concerned this was some kind of commissioning problem, some kind of parameter problem, but at the end was energy problem. So we had to add another rectifier to be able to support all the power consumption of the site. So we work a lot with VIAVI, VIAVI. We have this base station analysis, not for 5G. Here we were just checking the spectrum, to see if we could just check their interface. But we use a lot of these equipments to run the cables, make sure the connectors are done properly. We also have a fiber microscope integrated with the solution, so we could check the fibers to see if there's any how can I say, any problem with the fibers, in the microscope, to see if the nucleus is all clean. So we had all this set up to test. Also with Keysight, Nemo Solutions, we had a Z3 phone to perform all the collection data, and we use this collection data to feedback on the propagation model, so we could calibrate our propagation model. The results are very different, when you consider the US market of Canada or all the other countries, we have these construction differences, even between the same kind of material. For example, drywall in Brazil is different from drywall in US, is different from drywall in Mexico. So our technical team, we are always collecting this data and feedback to the IBWave to have the most accurate predictions as possible. And so also we were very well prepared here. And another thing that we want to check is the new state in 5G, the inactive state. So if we look at 4G and 3G, we have two states of the mobile phone. We have the idle and active. So here we have a new one that's inactive, and we want to see what happens when this user equipment change from inactive to active. How long does it take? Is the data transparent enough to not show any impact on this kind of performance? So we were very happy with the results. So this is the site in question. As I mentioned, is next to the airport. Here's the Santos Dumont Airport. It's a domestic airport in Rio de Janeiro. This is one of the most iconic locations in Rio de Janeiro. It's very beautiful, and it's very busy also. So this is the entering point for the city of Rio de Janeiro, and this one we always had a concern. When we are running a design, we need to be very thorough in the details and how we're going to model this system to support our projects, And this concern comes from to not over design or under design the solution. What we always aim for in QMC is to have the best TCO solution as possible for the operators. This is one of their visions: enable connectivity and resolve client needs. And whatever solution that we need to deploy, we are able to run all these kinds of solutions. So another curiosity here. Remember when I said that the operator's equipment was far away from our head end? The operator equipment is around here, on this location, and here we have all set of antennas also covering the airport. This airport is a location that's protected by a government agency that protect historical buildings. So this one cannot have any indoor installation here, you cannot have any impact, visual impact. So we do all the coverage inside the airport from this location. So here was one of the main results, to collect this data and to see, how our prediction, our propagation model, what's the result of our propagation model? Are we accurate enough, and so on. So we start evaluation. Before we had done a calibration, let's say, of the materials. We collect these materials on the internet, some research. We collect this from another entity here in Brazil, that has studied about propagations, signal, RF signals. So we collect this from several books. What's the brick penetration loss, for example, for 3.5, and we did a previous calibration, but you can see that the results were not what we expected to achieve. So I say, okay, we are on the right path, but we still need to calibrate more. And then we can see that our samples, the distribution of our samples are very spread across neg 10 dB and 10 dB, which is bad, considering that we are dimensioning a solution. So we start collecting data and feedback the propagation model until we reach what we consider that was more feasible. And then we can see that most of the samples are between 0 and 5 dB, which give us a very good results. So the idea is to have the propagation model very well calibrated, and in this way we can have pinpoint solution, dimensioning. We are not over designed, or we are not, which is worse, we are not under designed with these for this kind of projects. So here's just to share, we collect a lot of data. For example, below the antenna, 1, 2, 3, up to 40 meters away from the radiation point. So the idea was to create a curve where we could create a correlation between STS-RSCP, SNR, part of the signal, uplink TX power, and build this curve so we could see how the signal would behave in different environments. So we have this for open area. Now we have this data for very dense area like the food court I was mentioning, how the body loss will affect the prediction, how the body loss will affect the collection of data, how the body loss will affect the propagation of the signal, all the obstructions that we have on this dense area. So now QMC has this data to support this challenge. We know if we are in an open area, what kind of adjustment we need to do on the prediction. If we are talking about a hotel lobby or a shopping mall, how we can adjust the prediction to have the better result. And all these lead us to be able to provide the best TCO possible for the operator. So here's just a sample of the results. The system was built to support 4 operators in the neutral host environment. Of course, we cannot support with just one irradiation point 4 operators. If we need to support 4 with the MIMO 8x8, we would need 2. But for MIMO 4x4, we can support all the 4 operators. So in Brazil, we have 4 operators now that won the auction, and each one of them has 100 megahertz bandwidth available in 3.5. So in this configuration, we are working with one operator that's active on the system, and we can see these results. If we look here, we can see that the MIMO 8x8 is very different from 4x4. So there's 2 reasons here. The first one is our equipment test is limited in 4x4. We tried to get a CPE 8x8, but we were not able to find it on time. We got our hands on one later, but as I mentioned, we only had 30 days to run all these tests. Very unfortunate. But the main point here is that as we move with the POC, we start to run those tests and look for parameters that we could optimize. And then we had some findings. For example, when the Huawei, Ericsson, they use this kind of equipment that is not the active antenna, they have a calibration port on their AU. So this calibration part has a huge impact on performance because now we are indoor, we are working with very few being IDs, you are not working the full capacity of the equipment. And if it's an outdoor deployment, this calibration port is very important to see how the delays between different ports, to keep this time alignment error in check, between different ports. But for indoor, we're not going to have this. We are just transport all the signals on the same fiber link, and they are all being radiated on the same point. So when we turn off this calibration port, we had a better performance in 4x4. And there was other parameters that we checked. For example, how the system will manage this user equipment report feedback, the uplink signal about the MIMO availability. So should we keep the PMI fixed, for example? Should we configure the system to have this pre-coding matrix indicator fixed, or should we have this sound reference signal in the uplink dynamic allocated? So this match of configurations that give us the best performance. And we arrive on a configuration. We found a configuration that we consider to be the optimal one for indoor deployment, and this is the results that we got in the 4x4. Okay, and here you can see the signal level. So very close to the antenna, a little far, up to the edge point. And here you can see, when we are in NAG 95, we don't have the 8x8 signal, and this was another find. When we have 8x8 deployed, we have the signals being radiated. They sum together. We have a construction interference, and then we have this around that what we could observe around 10 dB gain on the propagation area, on the signal propagation. So this is why we don't have negative 95. So for some conclusions, when we see today, we invest a lot of training. So we had all our technical team, all our technical sales team, implementation team. We invest a lot on training of all of this person. So in the beginning of this year, we joined together with university in Brazil to have the 5G training to all of them. We also invest heavily in certification. So 100% of our team is level 2 certified in iBwave. And iBwave for us is very important, is what provide us the tool to support the market, is where we put all our efforts to come up with the solutions for all these RF challenges. And we also have 30% of our team certifying level 3. Another thing that we do, and we will keep doing, is calibrate the propagation model. We have done this extensively in all our deployments. We collect data and we feed this back to the prediction tool. And we will keep doing this the same way for 5G. So if I believe today that we are the company that has the most extensive database regarding materials, characteristics, and penetration loss in Brazil. So we have all kinds of materials, and with the prediction very accurate. And the tools, that we need, all the equipments to support the measurements on field. We invest a lot on this. So we also in train, how to operate these equipments. I think we are the only neutral host in Latin America that give this kind of attention to this technical side. So we have our field team, we have an OEM team. We do preventive maintenance on our sites. We do preventive maintenance in RF, in the equipment, in walk tests. Every 6 months we collect new walk tests to see if there's that hasn't had any physical interference in our system. And we find we faced a lot of kind of different situations. We have one case that the guy cut the cable and just put a silver tape on the cable back. We had a shopping mall that just simply rip off all the antennas. I mean, we face a lot of situations. So the OEM team is very important to keep the systems operating for 10 to 15 years. And I couldn't finish this, without showing here some of the peak results that we got. So keep in mind, this was the first 5G indoor case. The system is ready. So what's happening in Brazil now? Yesterday we had the official launch of the commercial 5G network by the operators. And now we're going to start seeing this movement across different capitals in the country. And the reason that we are having this kind of schedule, for different countries, because we still have some interference with the satellite systems, and we need to clear this spectrum, but it's happening. And soon that we reach the time to activate the network in Rio de Janeiro, the system is already installed and is ready to be commercially launched. I need to extend my thanks here to all iBwave team, to make this happen. Very good to be able to share this with all of you guys, and the entire QMC team that believe in this project and support this project. Both the engineering team, the implementation team. We have a huge venue acquisition team. They were paramount on this effort. They worked with the venue. The venue gave us full accessibility without any compromise. Let's say that we were there every day. Remember, we only had 30 days, so we were there 24/7, using the walking the premise of the shop. All the operator team that support this project, we need to thank them, all the engineer guys, the planning guys, transmission guys, all the technical part of the operator, and our partners, World Schurz, VIV, Keysight, that provide us with all this equipment for testing. They were very important to achieve these results. And with this, I close here my part. And
All right.
I'm available here to answer all the questions the best way I can.
Perfect. Well, thanks so much, Ricardo, and appreciate you joining us. And thank you, Milton. So we do have a few questions here, and we'll try to make our way through them best we can. So the first one, I think, Milton, this one would be more for you. Does iBwave support multiple subcarrier spacing design? That is, if I want to configure both 30 and 60 kilohertz subcarriers, can I?
Yeah, we can support that. Not that same system. You need to simulate two different systems, and in order to evaluate two different scenarios, right? But yes, it's possible. Yeah.
Okay, great. And I'm not sure who wants to this one, but the reflections are a real problem for indoor, ?
I can talk about this one. In my opinion, yes. We had a lot of cases that we didn't consider the reflection, not just 5G, but former LTE and 3G. And then when you go to the practical side of the implementation, when you run the test and you activate the system, you start to see a lot of interference between sectors, for example. And this is because we didn't account for this kind of situation. In Brazil, there's something that happens. It's not so usual now, but up to last year, the operators were activating what they call mixed mode. So they have 1800 radio and mixed mode with GSM and LTE, and we had to put, they don't run the frequency plan as they used to do. And so they activate a lot of GSM channels, and this interference, this reflection became a real problem. We had a lot of interference in the GSM system.
Yeah, and just adding a little bit more, depending on the venue, you have a lot of very specific effects that you have regarding the reflection, like the wavelength guide, right? So especially in corridors, in some special long corridors, you have some effects coming from the reflection, right?
Okay, great. Thank you both. And then a question here for Ricardo. Does QMC expect to have more indoor designs with 5G, or what's the status on that?
Well, it's hard to measure, how much will be this increment, but we do expect to have more. But most important is to be prepared for it. So today we have we are very well prepared. We are very well positioning. We keep investing in the training, certification. We have this experience to share. We already got a small rollout for 5G indoor, and we are very confident that we will be able to support whatever needs, whatever challenge the operator has in all our markets.
Great. And I guess for either of you, have you seen or worked on any projects that are using beamforming?
We did one in 2019, but I say it was a very special project. It was exposition arena, where we deployed 2.3 and 3.5 with massive MIMO antennas that they use beamforming. And now we are also working on the same arena to deploy this for all other operators in 3.5.
Okay.
And I believe it's being very supportive on this, the capacity that we have to estimate the beam interferences, to activate beam by beam, to see which way each beam is pointing, how we can achieve more coverage. We can aggregate the beams to have a full coverage, for example, or evaluate per beam. So this is very important. One of the best practices for this kind of prediction.
Okay. And then a question around the trial is, how long did the whole trial or POC take?
Yeah, so very unfortunately, we had a very short time. The government only issued this permit for 30 days, and 30 days was from the beginning of the implementation to the end of the trials. And as I mentioned, our original plan was to run all different set of scenarios, but we had to choose one and go ahead with it. But we already got another opportunity with a different operator that we are doing in a shopping mall, and we will start this very soon. And then we're gonna have time, because then probably the rollout of the 5G commercial launch will catch up with us.
Okay. And a question for both of you that just came in, or if anyone has a opinion on this one, is how many 5G deployments are you seeing in rail tunnels, or do you think there will be per year? Per your information on the market right now, is that popular deployment or?
What I have saw, this is my personal experience, is that usually they cover the platforms, the stations, but in the tunnel, when it's available, they are limited to lower frequency, for example, 2.3. And I believe the reason for that, I'm not sure, would be the cable. When we are using a coaxial cable, we have the skin effect, and to run this through 3.5, for example, through a coaxial cable will be very hard, considering the length of the tunnels. So maybe to have a mixed solution, with antennas and fiber to the edge points, with external antennas attached to it, something like this.
Okay, great. And
yeah,
then maybe
we can ask for the US team as well, Kelly, for more information about some projects like this in US. Here in Latin America, we don't have much deployment in 5G yet. I know that we have not a 5G NR system, but in Chile we have some 5G DSS systems in the metro system, but this is the only deployment that I know here in my region.
Yeah. Okay, makes sense. Okay, and with that, so we don't go over, I'm just going to make that the last question and wrap up the webinar. So a big thanks to you, Ricardo and Milton, and a bigger thanks to everyone who joined us on the webinar today. Really appreciate you taking the time to be here, and hopefully you enjoyed the presentation and found the content valuable. Again, we'll send out a recording to everybody. So thank you very much.
Thank you,
Kelly. Thank you all.
Everybody. Yeah. Bye-bye.
It was a pleasure. Thank you very much. Bye-bye.